Very much. My name's David Godwin. I'm the sales manager with GAMIC GmbH. So GAMIC is a weather radar and data processing company. We provide weather radar hardware solutions and software solutions. GAMIC was founded in 1988. We're based in Aachen, northwest Germany, so on the borders with the Netherlands and Belgium. Next slide. So since 1988, we've been developing a whole range of technology for weather radar. So we provide solutions for X, S, and C-band radars. We provide those as the transmitter technology. Also, we provide the transmitter technology in magnetron, klystron, and solid state. In fact, we've been manufacturing solid state radar since 2007, when we provided a system to Saudi Arabia. And since then, just the next slide, please. Oh, no, sorry, just one back. That's fine. Since then, we've provided over 300 radar systems, or technology into radar systems, which includes GAMIC technology, over 90 solid state systems, as I said, in S, C, and X band. And since 2019, we've actually provided 30 complete systems, so 30 complete radar installations. So in terms of our product portfolio, we do X and C-band Doppler weather radars. We've got an X-band Doppler wave sensing radar, which we developed in partnership with a US company, which, as the name suggests, does specific detection of waves. We do a range of signal processors, digital signal processors for the full range of wavebands. We have a comprehensive software suite for control of the radar for extraction and visualization of weather products. And there's a whole host of networking features, web views, etc. that come with that. We have a specific product for basically a weather signal processor for air traffic control solutions. And that specifically means it plugs into an existing air traffic control system, and then you can actually detect weather events, precipitation within about 36 nautical miles, and very importantly, you also get wind shear information as well. And on top of that, we can also provide customized services and solutions. Next slide. So yeah, just very briefly, just to expand on the product portfolio. So we have a C-band, GMWR C-band, dual pole radar. The 25 dP is the magnetron X-band, and then we have an X-band solid state, the 1000 series, and then the wave sensing radar, which, as I said, was kind of specific high seas applications where you're detecting waves in terms of predicting ship movements coming into harbour, that sort of thing, and then the airport weather solution going into for air traffic control applications. So just a couple of use cases I'd like to talk through, and really kind of the theme of today was also about the last mile interaction with other solutions. So I wanted to touch on this. So in this case, we were actually working with the city of Aachen, so our home city. And we partnered with Kistas, who are already also at the event, and actually also based in Aachen, as it happens. So we installed one of the dual pole magnetron radars in a location within the city, and then we could take the data outputs from that system and effectively inject it into the HydroMaster system from Kistas. And this has enabled the Aachen local government to then gets very accurate weather data and analysis, really helping them with issues with hydrology, climate change, etc. So that, as I said, was a nice example of the ability to collaborate and actually plug into third-party solutions. Here's another sort of quite interesting application. So this is with FUNSEMI, which is the Hydrological Meteorological Foundation in the state of Ceará in northern Brazil, near the larger town of Fortaleza. But this was actually an installation at Eusebio, which is a smaller town in that state. And in this case, they needed to add a dual pole radar for monitoring of weather within that region as they're obviously experiencing some severe climate challenges. Some interesting challenges with this are also being quite close to the coastline. There's a high level of salinity, so basically some fairly tough conditions to actually operate a radar in. If you just go to the next slide, it's just a nice video if it runs. Sometimes it's just nice to visualize what these radars look like. So in this case, we actually, with a local contractor, were able to install it on a purpose-built tower up sort of 30 meters high. This, as you can see, is like the final stages of installation. So it's an X-band solid-state radar, so relatively small, quite easily kind of maneuvered into place on this crane. And as you see, using this tower, you can get a fairly uninterrupted, uncluttered 360-degree view of the local area. You're getting sort of a range of 150 kilometers with the X-band. I think this last shot just gives you an aerial view of the final installations. And once this runs through, if you just a quick snapshot. So actually, this is now on the FinSemi website portal, and actually you can just get this as an accumulation map from the radar, and that was just a screenshot I took just to give you an idea of kind of the utility of these tools, that you can actually have them online, and so people can actually see the actual data output. So it's quite neat in that sense. Excellent. So this was an interesting project. This was a project we worked with EEC, the US radar manufacturer. And this was with the Deutsche Wetterdienst, the German weather service. And there's been a lot of talk about magnetron, if people are aware of it, the difference in transmitter technology between magnetron, which is slightly older technology, and also klystron, and then solid state. Now, actually, solid state, a lot of people talk about, it's been around and we've been using it for almost 20 years, but it's becoming much more prevalent now. And the Deutsche Wetterdienst, the German weather service, were interested in doing a direct comparison between a magnetron and a solid state transmitter. So, as I said, in cooperation with EEC, we built a system. And actually, if you just click on it one more time, it just gives a bit of an exploded view of the image. So you can just see, we basically built a cabinet with, we had the magnetron transmitter technology on this side. Sorry, the magnetron is on this side. On the right-hand side, the left-hand side contains the solid-state amplifier. And in the middle, we have a complex switching mechanism, essentially feeding into the antenna. The idea being that the antenna would then do one complete scan volume with the magnetron transmission, and then the same scan, but with a solid state. So as near as you can do it, there's obviously a slight delay. You've got a few minutes to do one each scan. So within minutes, you're measuring the same volume of sky. It will have moved a few minutes, but it's good enough for getting quite a good comparison. And if you get the next slide, maybe hard to see without really looking closely, but can you tell the difference between the two outputs? So I guess from this range, the answer is no, they are very similar. So the left is the magnetron output, the right is the solid state. There is a little bit of sensitivity degradation on the solid state due to the technology required to do pulse compression, but overall, I think the overall effect was actually a very good comparison in terms of showing up the utility of a solid state amplifier. And this is the raw HV data, and again, very similar outputs, just a slight change in sensitivity right on the edges if you look very closely, but overall, a very satisfactory kind of experiment in showing the relative performances of the two transmitter technologies. This is right up to date, so kind of stock press, but very recent. In fact, as early as last week, the team. So this is really a partnership with Hensoldt, our local partner here in Africa, who are also here at the event. This is really a recent award by the South African Weather Service for 2 X-band radars for Western Cape. And we're actually just in the process of, we've just actually done site selection last week, in fact, in Dassenberg and Prince Albert. So over in Western Cape, two areas within Western Cape. So those are 2 solid-state X-bands, which will be installed. I think the first one's going in November and the second one in April. So those will be, I think, the first of GAMIC radars in South Africa. Yeah, that's a really interesting project. And as I say, working very closely with SAWS and also with Hensoldt here very locally to here. And I think, again, hard to see, but you can see the coverage. Maybe you can. I'm trying to see there's a red coverage circle for each, so that's just giving you an indication of what the outputs will be and what the coverage will be like for that. So that kind of gives you an idea that you're getting some pretty good coverage there. Well, I'll give you some examples of some of the other technology that's available and what we can provide with GAMIC. And it's just not simply about just getting simple weather images. You can also, in this case, we have algorithms which detect second and third trip reflections, which obviously give you a false impression of what the weather's actually doing, because you're just getting the second trip from the signal generation. So in this case, you can see the processor, the algorithm will detect what is second and third trip reflections and then remove them from your final radar image. So it just cleans up the image so the data is clean and accurate. So that's just a very nice indication of what you can do with the technology. And here we're looking at detecting interference on the left. Again, hopefully you can see it. The red flashing blocks is where we detected some a pulsed radar, which is obviously been sent by antenna. So the processor can then detect that and then remove it from your image. And on the right, which is quite interesting, is actually detecting RF interference, basically Wi-Fi interference on C-band. So obviously there's quite an issue with C-bands in particular built-up areas, particularly where the spectrum is shared with things like Wi-Fi, 5G, 5 gigahertz Wi-Fi, and other signals. So the processor can, the GAMIC process can detect that and then have that flash it up so you're aware of it and then remove it from your image. This is just an indication of, and again, a fairly typical problem with radar, which is clutter, and that can be from buildings, from birds, from whatever. So what we're trying to show here is on the left is a clutter map, but without WTC's wind turbine clutter. So it's very distinct from generalized clutter and wind turbine clutter, but we can actually detect both. So on the left, the image is detecting and removing general clutter, and then on the right, it also detects wind turbine clutter and then can remove that. Obviously, with the growth of wind farms, that's going to become an increasing issue. So yes, the next slide. This is just an indication of wind shear detection and basically throwing up alerts and nowcasting. So again, this image on this screen is pretty hard to see, but there are actually some wind indication bars of wind and direction, and then we throw up wind shear indicators, which are these red dots here, which again, if you're actually on a radar screen, if you're on your PC or whatever, you see those very clearly. It's a little bit hard to see. And then on the horizontal and vertical bars, you're getting nowcasting showing the kind of immediate forecast for the next short space of time. So that's, again, something we can do. Again, this is also, again, showing the tracking of storm and storm analysis and showing the direction and intensity of the storm, and also how the visualization tools work and how the utility of those tools. Just one final example. This was with, again, the German Weather Service, and this is where we networked 18 radars within Germany, really just showing how we can actually take 18 separate radar inputs and then blend and composite the signals so that you're not getting any aliasing or overlap. So you actually then, what you get is a continuous image across the whole area of interest. So that's something we actually did some time ago. So it's something that is very much something we can do. So really just in conclusion, we've been around for more than 30 years, we're a leading provider of technology for weather radars. Based in Germany, we work very closely with local partners, so we have local partners, as an example, Hensel here in South Africa, so we always work closely with in-country partners so we can deliver a complete service. And we've got experience in all the range of technologies, magnetron, high-strong and solid state, SC and X-band. We've been managing projects globally. That's all. Any questions?